Okay, so in the previous video, we talked about blobs, and it's kind of probably confusing at this point. We said blobs store the contents of files, but not even the file name, just the contents of files. Now, that's fine, I guess, if we want to do things like we have been doing, where we're storing a couple of words or the content of a single file and then spitting it back out, asking Git to return it back to us. But in a large project with hundreds of files and nested folders and a crazy structure, if I can just tell Git, check out this commit or switch to this branch, and it can change all of those files, all of those folders, it might delete some in my working directory, it might add a whole bunch of stuff. How is it able to keep track of that structure? It's not just the insides of the files, it's the relationships between the files, it's the structure of the directories. So that's the role of tree objects. Trees are Git objects that are used to store the contents of a directory. So blobs store the contents of a file, and trees store the contents of a directory. So trees actually contain pointers that can refer both to blobs and to other trees. So think about it this way. If we have one folder, and inside that one folder there is one file, well, Git would represent that with one tree, and that tree would point to or refer to one blob for that file. So each entry in a tree, you can visualize it like this, contains the type. Is it a blob or a tree? The two things that a tree can refer to or can reference. And then for each entry, we've got the hash. So this is not the commit hash. This is a blob hash in this case, right? We saw a blob like this one, 1F7. It's the contents of some file. Well, here's a tree, and it references that contents, that blob, 1F7, and it gives it a name, app.js. And then down here, it references another blob. Here's the hash. So it's not storing the contents in the tree. That's what the blob is for. This is the structure. This is the content. So we end up with references to blobs, but also references to trees, because we have nested directories often. So in this case, in this tree, we're representing app.js and readme, two files, two blobs, but then there's an images directory and a styles directory, and each one of those would be represented with its own tree. And there will be blobs most likely in there, and then maybe more trees. So hopefully this diagram helps explain it a little bit. If this is my folder structure, two files, index.html, main.js, and then a directory, nested, called styles. App CSS is inside and nav CSS is inside. Well, Git would have a single tree to represent this entire directory. So we've got a tree, and then it has a blob that it refers to, and it names it index.html. So that's the contents of that file. Remember, the blob itself does not store the name. The tree stores the name, and then it references the hash of that blob. So this is that connection between a file name and the contents. 1F7, that's this blob. Okay, so then the same thing for this main.js file. It points to that blob, whatever that hash is, and names it. But then it refers to another tree called styles, and that tree contains two blobs. App.css refers to one blob, nav.css refers to another blob. So here's a more fleshed out diagram, complete with the actual hashes that match. So you can see we have a tree. This tree has its own hash. Every tree has its own hash. It's a Git object. So this is stored in the objects directory. And we see there's a blob, 1F7A7 right here. So that is hashed and stored, and it's called index.html. Here's the blob. This is the tree that refers to it. Here's another blob, BE321, that matches this, and it's called main.js. It's a blob. So whatever is in that file is the contents of a file called main.js. And then we've got a tree, styles, so that's a directory, 98287, that's the name of that hash. It's not the name, but that's the hash we see here. And that tree stores two blobs, 10ABB, which is app.css, and then FFE77, which is nav.css. Those are the contents there. So the last thing I'll show you in this video, we're not going to make any trees right now, but I'm going to show you that in an existing repo that has history, we can view trees, just like we could use cat file to view blobs. We can use cat file to view trees. And we don't have a tree to reference in our own repository that we've been working on, but this is the React repository or any repo we've worked on. If we have some commits that we've made, and we've added some files and folders and stuff, we will have a tree, at least one. As we'll soon see, every commit references a tree. Anyway, this command, get cat file -p, we've already seen, but this syntax, master, and then this caret tree, that syntax is a particular way to refer to the tree object that is pointed to by the tip of our master branch. So the last commit on master, every commit refers to a tree. This just gives us the most recent tree. So let me show you that. This is that React repo that has all sorts of commits, lots of files in here. You can see them, a couple directories, okay? Really just fixtures, packages, and scripts, and then files. Now, if I do get cat file -p, and then I'm going to do that weird syntax. So master and then caret above the 6 tree, like that. And I hit enter. It prints out, it pretty prints a lot of stuff. We could ignore this over here. This is the file mode. Doesn't matter. But it also shows us if it's a tree or a blob, and then the hash for each, and then the name. So we can see for each file, we've got let's see, circle CI, that's a file. Somewhere over here, it's a hidden file, so it's not showing up there. Let's keep going down. Here we are. Authors, that's a blob, right? So the contents are stored with this hash. And I could actually view the contents if I wanted to. Let's take a look. How about, sure, the README. I could copy this, I'll keep it on my clipboard. But then I'll also show you there's trees, right? Here's a tree object for the fixtures directory. Here's another one for packages and another for scripts. There we are, the 3 directories. So I'll just show this here. If I take this hash that I copied, this was a blob hash. Remember, I can do cat file -p, if I can type, here we are, pass in that hash, and it's showing me the contents of the README. This is all the stuff from that README file. So quite a bit of stuff that it's storing there. It's not too much. The last thing I want to show you is that another option for this cat file command is to actually tell us the type of something. What type of get object? If I do -t, it tells me it's a blob. But if I instead do this, get cat -file, well, actually, why don't I just show you? If we look at the tree again, if I pick one of these trees, like this tree object that represents the fixtures directory, if I do the same thing, get cat file -t, with that, it tells me it's a tree. So there are 2 types we've covered so far, blobs and trees. We haven't seen how to make a tree in the same way that we saw how to make a blob manually. I showed you an existing repository, this React repo, but all that you need to know for now is that trees represent folders, the structure of a directory. And inside of a folder, we can have files, but we can also have other folders. So the tree itself contains, it's not an actual table like you see here, but inside of it, it stores a bunch of entries, references to blobs and to other trees. Each one has a name, and each one has a hash, a blob hash or a tree hash. And each tree, as we've seen, has a hash. And that's all I'll say for now about it. I know it's getting kind of complicated, but this is hopefully all going to come together soon.